Autopsy supports the common disk image formats, such as RAW, DD images, either a single file or split over multiple files. E01s, you can bring in RAW images or E01s of smartphones, such as Android or iOS, virtual machine formats, etc. Pretty much all the common formats you can bring into Autopsy. General process is you'll point Autopsy at the first image, and it will do the rest. All it needs is the first image in the file. If you give it E01, it'll find E02, E03, etc. If you give it 001, it'll find 002, 003, etc. One note here is if you bring in an E01 file, we will not do any validation. Our goal is to get data analyzed as soon as possible, and we don't want to spend time validating that E01 file. You can do so afterwards. There's modules that run after the data has been added to the database to verify the E01, but it's a secondary step. It's not done as part of adding the data source, whose main goal is to just scan the system looking for the files to add. So when you add a disk image, we're going to use the sleuth kit to analyze the contents of the image. The sleuth kit is a set of open source forensics tools I've been involved with for many years. That came out of a set of tools. It's called the Corners Toolkit. And they are going to detect volume systems that break the disk into partitions and file systems that organize those partitions so that files can be stored and read. So on the volume system side, volume systems, as a refresher, organize a disk into one or more volumes or partitions. They generally have some kind of data structure at the beginning of the disk image that show how it's going to be organized. And Autopsy and the sleuth kit will support DOS and GPT partition tables, which are the two most common ones, as well as Mac and BSD and Solaris and some older legacy formats, if you will. So here's an example of what a disk image may look like, where you have two volumes and some unused space in between and at the end. Those unused spaces will be turned into files so that you can see them from within Autopsy. And essentially now, the sleuth kit and Autopsy will go into each of the volumes and the unused space and try and make sense of it. So they'll look for a file system inside of each of those. If there's no volume system found at all, the entire image will be analyzed for a file system. An example here is flash media or USB devices. They don't typically have volume systems on them, but they will have the entire thing be a single file system. So file systems are data structures that allow operating systems to store files. Typically, they are located inside of a volume or partition, or as we said before, the entire disk image for a USB device. And the sleuth kit and Autopsy support common formats such as NTFS, FAT, exFAT, HFS, ISO, EX2334, YAFS, UFS, etc. Orphan files are deleted files that no longer have a parent folder. So when a file or folder is deleted, sometimes you can recover it, sometimes you can't. It all depends on the overall system usage. Sometimes you'll get a file that still can be accessed to. You still have all its timestamps, you have its name, you know where its content is, but its parent folder has been reallocated, and we can't get to it anymore from the root of the file system. These are called orphan files in Autopsy. We will put those in a special place. You will see a $sign orphan files folder, and inside of there, you will find the orphan files. One note, on FAT file systems, it can be very time intensive to find the orphan files. The reason is that we need to look into every cluster and sector in the file system to see if it has these orphan files inside of them. This can be really slow. So when you're adding in a FAT file system, there's a checkbox that allows you to turn this feature off. So if you are really pressed for time and you want to make sure you're getting results as soon as possible, you can disable the orphan file searching process for FAT file systems. I want to mention carving. So carving often comes up in the course when we're talking about the concept of unallocated and deleted files. So carving is a process for recovering deleted files without relying on file system knowledge. It relies on the file structure internals. So it knows about a JPEG file, it knows about a PDF file, it knows about a Word document, it knows how they start, maybe how they end, and it basically uses that structure to piece together files without having to rely on any kind of file system data structures that are pointing to where the content starts and where the content ends. So here's an example. Before deletion, we have a file name called file1.jpg. It's pointing to some data structures that then point to actual blocks on disk where that JPEG file is being stored. That file is deleted. After that, there's the name and the metadata, and those are now separated. The content is still there. That picture is still down there on the bottom, but nothing is actually pointing to it anymore. And as part of that carving process, we will scan along, we will find the beginning of the JPEG, we'll find the ending of the JPEG, and we will group them together as one chunk. We do carving in Autopsy. We use the PhotoRec tool. It's an open source carving tool. It will run on the unallocated space files that Autopsy and the sleuth kit found, and it will place them under a special $sign carved files folder. You'll see a bunch of these $sign files. These are folders and files that we create to provide some structure to the data you're seeing. One caveat here: this is not actually being done when the data source is added. The carving is being done by the ingest modules that happen after the analysis begins. I just bring it up here on this notion of how are we getting files out of the system and how are we getting deleted files. So some deleted files will happen as part of the adding data source to the case, and sleuth kit goes through it. Others will be found later on in the analysis as the ingest modules carve up the unallocated space and bring files out. Speaking of unallocated space, you will see unallocated space in Autopsy as a file. So what Autopsy and sleuth kit do is they take these blocks and sectors that are no longer being used by files and they're just hanging out there, and they group them together into files that represent unallocated space. They have a special name. They will look like this. They will start off with unalloc, and then underscore, and a bunch of numbers. You can see an example here. The numbers don't really mean much to you. They're just a way of making sure that we have unique numbers for them. But the basic idea for you to understand is that the blocks and sectors that aren't being used by files, the unallocated space, are all being assigned to these files so that all of the ingest modules can analyze them and keyword search modules can find them. And so when you see a keyword hit that happens in one of these unallocated files, it's essentially a hit that you're finding in unallocated space. So how do you add disk image? Well, we saw many slides ago that when you go through the wizard process, you pick the type of disk image that you want, data source that you want to add. If you specify disk image, you'll get a dialog such as this. You can navigate to the path of the disk image you're adding. You can choose to ignore orphan files or fat file systems. You can choose to pick the time zone that it came from, as well as sector size. And then you can optionally specify some hash values if you have them as part of a raw image and they aren't part of the E01. Limitations for disk images. As of right now, we do not support RAID, logical volume management, or dynamic disks as they're called in Windows, or BitLocker. These are all on the roadmap, but in the current version, they are not supported. Another common data source that people add into Autopsy is local drives. A local drive is a drive on your system, like a C or an E drive, that you want to analyze them. The use cases here are if you encounter a system you want to analyze that is currently running, you can run Autopsy from a USB drive and analyze that live running system. In that case, you'd be analyzing the C drive of that computer that's running. Another use case is that you have your trusted analysis computer and you plug in a USB drive from some external media, perhaps through a write blocker, and you want to analyze that. In that case, you'd be analyzing a G drive, an H drive, an I drive, or some other higher letter. So from Autopsy's perspective, analyzing a local drive is pretty much the same as a disk image. We're going to scan for volumes and volume systems. Inside of those, we'll scan for file systems, and then we'll add the files to a database. Now, if you're going to analyze on a live running target computer, the C drive, or maybe the D drive, you will need to be administrator to access those drives. One other note, analysis cannot be performed once that USB drive is removed. So if you have that data, and if you're plugging in an external device, and it comes up as the E drive or the F drive, if you unplug it, Autopsy will probably be unhappy, because it's going to try to read that, and it's now gone. So here's an example. If you add in a local disk from the wizard process, you'll get a screen such as this, where you can select the drive that's available, time zones, same orphan fat file options as well, and this option down here, making a VHD, which we'll talk about in a little bit. So that option to make a VHD file allows you to make a sparse VHD image while you're analyzing that local drive. This is very useful for triage situations where you're analyzing that live running target computer. The basic idea here is that when Autopsy is reading that C drive, it's going to read in sectors, sector 5, sector 6, sector 7, and it's going to determine if it's already seen that sector or not. If it hasn't, it's going to make a copy of it into the sparse VHD file. As time progresses, this sparse VHD file gets bigger and bigger and bigger of all the data that's been read. And if you keep this plugged in long enough and analyze the entire drive, you actually get a complete image of the system if you keep it plugged in long enough. If you don't, and you unplug it after doing a quick scan, looking for just pictures, for example, then all you'll get is the information from the file system structure and maybe some pictures that were analyzed. We'll talk about this a bit more later on, but the basic idea of this VHD file is that it's going to make a copy of the data that you've read, so you can do later analysis on that results. To make a VHD file, you choose Make a VHD option. By default, it's going to make a VHD file inside the case folder. You can change to choose it if you want to. And the last option is to update database. And what this means is that once you're closing the case or you're done with your VHD file, then Autopsy will update the database to refer to that VHD file instead of its original drive path. So for example, if you had plugged in a device as an E drive and you were analyzing that, or it was the C drive on a live triage situation, and you analyze it, it's going to replace the C drive path with whatever was in your case folder for that VHD file. And you can then open it up afterwards without getting an error message that it can't find the C or the E drive. Another source of data sources that are analyzed in Autopsy are local files, also known as logical files. These are basically files that are stored on your computer's file system. They could be a collection of JPEG files or Word documents. They could be an L01 file. It doesn't matter. Basic process, you're going to specify a file or folder to add. Folders are recursively added in once you specify them. And we'll add in basic info about every file into the database. One big caveat here, the times are ignored. Oftentimes, we don't necessarily know what those times mean. They may have changed as those files were copied around from location to location. So those will get added in with all zeros as their timestamps. One other thing to note is that files are not copied or moved. Autopsy is just keeping a reference to where they were stored when you added them in. So if you were given a USB drive and you plug it in to do some quick analysis of that, and someone may take that USB drive back, you should copy them first to your computer before you add them into Autopsy. Here's an example. When you add in local files, you'll get a dialog to browse to a set of folders or files to analyze, and they will get added in as normal. When you add in a set of files or folders, they will get added in as a logical file set. So as we will see later on in the UI, they will be grouped together under a logical file set 1 or logical file set 2 heading. You can change that name when you add them in to the case. So a quick summary. Data sources are the things that you add to a case, and adding a data source simply means that its structure is analyzed and metadata about those data sources